We start from problem number 6. We have a system travels in a linear path with some acceleration because of two forces. The first one, F1, is 3 times higher than F2. And if F1 stops acting on the object, what will the object's acceleration be? So first we have two forces acting, and F1 is 3 times bigger than F2. Well, then afterwards only F2 happens. And I will solve this like that, but you can definitely tell me, Ms. Penzaki, like, don't you have any values to put? Like, why don't you ever put any values? Fine, do you want values? I can say that I can consider that F2 will be 10 newtons, or something, even 1 newton. And F1 is 3 times bigger, which means 3 newtons. And I will consider my mass to be 1 kilogram. It's the same thing. Alright? I will solve it however you want. So, what do I know? I know that in this case, the total force is F1 plus F2. And the acceleration, in this case, let's call it case 1. The acceleration here is the total force over mass, and the total force is found by adding these two. And as I know that F1 is 3 times bigger than F2, I can put it here and say, so this is 3 times F2 plus F2 over mass. That means that this acceleration is 4 times F2 over mass. I don't know if you see. So if I had values, that would be 4 times 1 divided by 1. I would find a 4 meters per second squared. What about this case? Now the acceleration now is the total force over mass, but the total force is F2. There's no other force. So I'm done, because I can see that the original is 4 times F2 over m, while this one is just 1 time F over m. That means that this is 4 times bigger than that. Or if I put the values 1 over 1, I would find 1 meter per second squared. So I can see that this is 4 times bigger than that. And no matter what the values are, this result will always be 4 times bigger than that, because the general case is this is 4 times bigger than that. Now let's go to the next problem. So right now, the difference now is that F2 is opposing. F2 is opposing. That means that I should subtract it here. Subtract it here. So that means that I would have a 2 here. And now my acceleration would be 2 meters per second squared. While here, the total force is negative F2, right? Opposing, negative. So in this case, it will be negative 1. So I see that the acceleration now changes direction. So if I had an acceleration here, it would be towards here. Well, now the acceleration is created only by F2. It's half. It's half. It's exactly half. And opposing.